Okay, so good day. So our topic for today, for steel design, is the design of the connections. Okay, so yeah, so the distance or the horizontal distance of spacing between the rivets or the bolts is called the pitch. And then for the vertical is the gauge. Okay, and then the edge distance is measured from the edge up to the center of the bolt. So as we have talked in the history of the materials, this connection, the first one is for single shear connection, then the second is the double shear connection. So just a recap, this is the single shear. So using the formula, shear stress is force divided by the 1 times the area. Okay, 1 is for the single shear times the area is the area of the bolt. There should be n, should be multiplied by n, which is the number of the bolts. Okay, for the double shear in this position, horizontal or vertical position, something like this, it is P over 2A. And also, it's multiplied by the number of the bolts, wherein A is the area of the bolts. Okay, so let's go to module. So uh, for the bolts, for the spacing, see for this one, this is the actual. Okay, for the rivets or the bolts, determine the spacing. Okay, for determining the spacing of the bolts, as it's having a formula Ri over Vq. This is the shear force resistance of the rivets. Then the I is the moment of the inertia of the hole. Say for something, it is in uh, this arrangement. So you're going to calculate the moment of the inertia of the entire section. Okay, so R shear force resistance, I moment of inertia of the whole section, I beam and the flat plates. Then V is the applied shear force, and then okay, Q is the first moment of the area. Okay, so select this one. This is the pitch. Okay, and then okay, yan binaliktad ko lang siya, no. So may gauge tapos there's a pitch. So those pitch is also the tributary. Okay, the tributary width for this one. Okay, so this is the application, and this is how it is going to happen. There's FB max, and then there's an FB. This is my X, and then sa Y connection. Okay, so yan. Okay, this single shear and then a double shear. Okay, for the tensile strength of the plates. Okay, ayan. In our steel design, we have ASD and LRFD. The common, okay, the common inputs include in the board exam nowadays is the load resistance factor designs, the LRFD. So through this, we could formulate the ultimate for tensile strength for tension yielding. Okay. Okay, so I already locked, no, I already locked the classroom because it's already starting. Okay, so however this recorded. Okay, so P ultimate P ultimate equals 0.9 FYA gross. So for LRFD, the ultimate capacity for the connection for tensile yielding is phi RN. Okay, phi, the capacity reduction factor multiplied by the Rn or the En, the nominal. So that is 0.9 FYA gross. That is 0.9 phi times FYA gross. How about for the ESD, sir? That is 1 over by the yung phi natin para sa ESD is 1 over by the factor of safety. So our factor of safety for ASD is 1.67. that is 1 over 1.67 PN. That would result to 0.5988, which is 0.6 PN. So that is 0.6 FYA gross. So those are the capacity under tension yielding. But for tension rupture, sir, that is simply 0.75 FUAE or okay, 1 over 2 FUAE. So, napagbaliktaran ata siya. 0.75 FUAE, this should be the LRFD. Okay. Points. Control C, Control V, Control X, Control V. Okay, ayan. So, 0.5 FUE is for the allowable tensile strength, which is 1 over 2. And then 0.75 FUE for the LRFD. Okay. So, ayan. So, this is for slot weld and plug weld connection also. So, for plug weld, this is the itsura niya sa plug weld. Okay. Then, welded connection is AN times the U, AG times the U for the welded connection. But then use the shear log factor. What do I mean by shear log factor, sir? Shear log factor is the factor multiplied to the area wherein pag hinatak to, itong connection na to, not all the bolts are equally stressed. That's why we are applying the shear log factor. Okay? So, ayan, yan din pala yung sa bolts natin, no? So, for solving the problem, okay, yan, this is the discussion for the strength of the material. So, balikan lang natin konti. That is Fy yield strength. Okay, that is the yielding strength wherein a certain material can still go back to its original orientation. Say for example, this rebar is being tested in a universal testing machine. Hinahatak tong bakal na to. So at Fy, which is commonly in solving problems to 45 megapascal, it will not yet deform. Okay, for that Fy for 245 or 415 for grade 60. Okay, for 15 megapascal. However, if we still continue to stretch this steel bar in the universal testing machine, may experience nyo yan pag nag-site na kayo, if you go on site as project engineers or inspectors, you could experience this one. If we continue to stretch this material, we could attain its ultimate strength. Okay, wherein through this one it will suffer already necking. Ganito siya, liliit yung part na to. Okay, parang magiging itsurang balakang, di ba? Magne-necking siya. Pero hindi pa siya magfe-fail. Magfe-fail siya, bababa na yung strength niya. Its strength will go down until it will fail. Okay, so maririnig nyo yan, mag-YouTube kayo ng testing, okay, of steel bars. Then you would hear a sound na malakas, okay, na parang pinutol. Imagine, puputulin nyo yung bakal, di ba? So maririnig nyo yan talaga. So it will come to its failure, which is you will get its breaking failure, okay, or the breaking stress. So ganyan yung nangyari sa lahat ng materials natin. So steel beam, steel column. Okay, so let's solve a problem for the connection. For the eccentrically loaded bolted connection. So as you can see in the problem, okay, we have 35 kilonewton on a steel bracket. This connection most commonly can be seen in warehouse design. Okay, so this can be seen in warehouse design wherein there is a bracket and there is a beam, tapos doon sa beam na yun papagapangin nyo yung inyong gantry, yung inyong cranes, okay, yung crane na sa magbubuhat ng mga equipments from one point to another. Okay. So, ayan. So, from the configuration of the bolt session, we have a bolt A, B, C, D, E. And it's uh, pitch of 150 and it has gauge of 100. Okay. So, from this connection, we will let, so what is the unknown here, sir? Determine the shear resistance of bolt A. Okay, so please take note na lang guys. The unknown here is determine the shear resistance of bolt A. The shear stress to be resisted by bolt A. So through this one, uh, first thing first, we are in need to determine first the center of the gravity of the entire bolt. So by conventional method, you're going to use the Baringa's theorem. Okay, but for this one, for board exam purposes, we need to find it the faster way. So we will using the calculator, the function of mode 3 to the linear regression. So we will let that point B or the bolt B at the center of the bolt be the origin. So pataas is positive, pakaliwa is negative, pababa is negative, then pakanan is going to the right is positive. We're just going to use the uh, uh, okay coordinate system. Okay, so at bolt B, we have 0x, 0y. At bolt A, pataas siya 100. So, sige, yung x niya is 0. Then yung y coordinate niya is 100. Bolt C, that is the x dimension niya or x coordinate niya is negative 150. Then aangat siya. It will go upward by 100. So, it has 100. So, we have also values for D and E. By Varignon's theorem, it was just an average divided by the, okay, it was just the average divided by the area of the bolts, wherein area of the bolts is just, for this one, nagawin lang natin na tigwa 1 yung area of the bolts natin. So, what will happen there is we're just going to make it average. So 90 and then 20. So there's negative 90 and then positive 20. Okay. Or through your calculator, uh, if you use the mode 32 of your F789 SGA, okay, shift ups and then 5, 2. Okay, you will get the X bar, shift ups up 5, 2. Okay, for the X bar, that's just simply shift, then ups, then 5, 2 upon inputting the values. For the, that is for the F789 SGA, pag FX599 and FX570, shift 1, shift mode 3 to, then per mode 3 to, tapos AC, shift 1, for 2. Okay, so shift 1 for 2. That is for the 570S. No, 570S. This one is for the 789 SGA. 789 SGA. That is for the X bar. For the Y bar naman, as what I discussed in the statics of rigid bodies, let's just simply shift ups 5, 5. So ito ay shift ups 5, 5. That is for the 789 SGA. For 570 is, let's just simply shift 1, 5, shift 1, 4, 5. Okay, this is shift 1, 4, 5. Okay. Okay, ayan. How about for the J, sir? By conventional method for J, we can get those values by x minus x bar squared, summation of x minus x bar squared, and then y minus y bar squared. But through calculator, we can already get the value of j, that is, okay, sige ha, input ko sa calculator guys, 0, 0, negative 150, negative 150, negative 150. Then for y, 0, 100, 100, 0, then negative 100. So for the j, that is just simply shift ups 5, 3 squared plus shift ups 5, 6 squared. So 11,000. Oops. So that is 55,000. That is 5 volts multiplied by, yeah. So that is just simply 5. Multiply natin siya sa shift ups 5, 3. Shift ups 5, 3. I-square natin yan plus shift ups 5, 6. I-square natin yan. Then we could easily get the value of j, which is j equals 55,000. Okay? So, ayan, no? So, 5 times shift ups 5, 3. Shift ups 5, 3 squared plus shift ups 5, 6 squared. So, we could easily get the 55,000, which is the polar moment of the inertia of all the bolts. Okay? So, it's up to you if you're going to use the conventional method or using the calculator for faster. Okay? So, yun, no? So, yung 5, saan galing yung 5, sir? Where does it come? It comes from the number of the bolts. So, 5 yung bolts, so therefore that is 5. Okay? So, itong shift ups 5, 3, that is just simply the x minus x bar, summation of x minus x bar. Then this shift ups 5, 6, that is the summation of y minus y bar. Okay? So, if it is bolted, if it is a connection subject for a moment, so therefore this is an eccentrically loaded connection, therefore it will carry an axial and then the moment. Okay, so first thing first, this 35 kilonewton, we will divert this 35 kilonewton into the centroid of all the bolts. And also, this will generate a moment which is 35 kilonewton times the moment R from the point of application up to the center of the gravity of the bolts. So therefore, for this moment and the moment, for this axial load and then the moment, it is the force, those are the forces that should be resisted by the, excuse me, by the bolts. Therefore, if we have vertical force, all the bolts will help each other to carry the vertical force. Since there's a force downward, the counter force to be reacted by the bolts due to direct shear bolt resistance is upward, which is PDY, which is Py over by the number of the bolts, that is 35 kilonewton divided by the 5 volts, that would result to 7 kilonewton. Therefore, each bolt resists a vertical force of 7 kilonewton upwards in order for the connection not to fail due to axial. Okay, so why did you put PDX, sir? Here, sir, wherein PX divided by N. That is the horizontal force. That is the horizontal force to be resisted by the bolts if there is a force horizontal applied on the system. However, in our connection, in our problem, there is no horizontal force. So therefore, just treat this PDX. The horizontal force is resisted by each bolt be 0. Okay? So that is the direct shear bolt resistance. What about for the torsional bolt resistance, sir? For the torsional bolt resistance, since the moment acting on the body is clockwise, so therefore, all of the bolts will help each other to counteract that clockwise. So they will act counterclockwise. So this is the illustration. Okay, so how it will happen, sir? That moment will act on the centroid of all the bolts. So from all of the bolts, from the center of the bolts, okay, from the center of the bolts, we're just going to make a straight line going to the centroid of each bolts. Okay, ayan. Now, from that point, since there's a force clockwise, therefore the resistance would be counterclockwise. So those counterclockwise forces should be perpendicular to that distance. Okay, so therefore, this force was a perpendicular. Then this force acting on C is also perpendicular. So as you can see, those red arrows can cause a moment which is counterclockwise. Yun yung ilalaban natin para dito sa moment na clockwise. Since force A is nakaturo siya ng paganyan, it is going in that direction. Therefore, the torsional resistance of bolt A horizontal is going left, and then torsional resistance of bolt A is going upward. So for bolt C, it is going left for PTX, and then the torsional resistance of C for the vertical is going downward. Okay, so as you can see, you could generate the PTY and PTX of each individual bolts. Okay. Okay, so how are we going to solve for the PTY and then the PTX? For the PTY at A, okay, for the PTY at A, that is MXA over by J. What does it mean, sir? That is torsional resistance of a PTY is the moment, which is yan, na-solve na-calculate na natin yung moment, that is 35 kilonewton, okay, multiplied by 0.25 plus 0.09 meters, which is ito siya, 0.25, that is 250 millimeter, and then the 0.09 meters, which is 90 millimeter, that is the x distance, which is from A papunta doon sa center of the gravity of the bolts, which is 90 pakaliwa ng A. Okay, going left of A. So that is just simply 11.9 times 10 raised to 6 Newton millimeter. So as what I say always when solving for stresses, especially the strength of the materials, at dito sa steel design, dapat yung forces natin should be in Newton, and then the dimensions should be in millimeter. Okay, so that is M. Then the XA, the XA is the distance from the center of the gravity of the bolts papunta doon sa, that's the horizontal distance from the center of the gravity of the bolts papunta doon sa ina-analyze natin na bolt, which is the letter A. So that is a distance of 90. Then the J, that is the okay, moment of the inertia, polar moment of the inertia of all the bolts, which is 55,000 millimeters squared. So therefore, the PTY, the torsional resistance of the A is 19.473 kilonewton upwards. Okay, so for this one, disregard the sign if positive or negative. What you will just do is upon calculation of this force, you will just indicate if it is upward or downward. Okay, so you will get that point dito. Ayan. Kaya napaka-importante nitong ganito. Okay, so if the moment, if the uh, what you call this, resultant moment is clockwise, therefore all of the balls will resist counterclockwise. However, if the moment is counterclockwise, therefore the bolts will act clockwise. Okay. How about for the PTX, the horizontal torsional resistance of the bolt A? That is just simply moment times the YA over by the J. Those moment is just still the moment that we use on PTY. Then the YA, YA is the distance from the center of the gravity of all the bolts going to A, which is, okay, 80. Okay. So since our origin is B, the center of the gravity of all the balls 20 upwards, which is 20. So distance between B to A is 100. So therefore the vertical distance between A to the center of the gravity is 100 minus 20. So that is 100 minus 20, so that is 80 mm divided by the J. So therefore we have 17.309 kilonewton. Okay, solving already for the shear resistance. What we are going to do is we're just going to make a resultant. P direction, direct x, torsional x squared plus PDY, direct y plus PTY squared. So since PDX of the bolt is 0, so that is 0 plus PTX. What is our PTX? PTX natin is 17.309. It was supposed to be negative na or dito. Dapat that is negative kasi pakaliwa. Then, PDY natin, due to action is 35, 7 kilonewton upward. PDY is 7. 35 divided by the 5, that is 7. Okay, PDY should be 7. Okay, yan. 7 plus yung PTY natin na 19.473. Yan. So, magka-calculate natin yan. 17.309 squared plus 7 plus 19.473 squared. That would result to 31.629. Or PDY is 35. 7. So this is 7. This should be 7 also. Okay. So plus 19.473, 17.309 squared. 7 plus 19. That would result to 31.629. Should be 31.629 kilonewton. Okay, ano ba to? So, ayan, kilonewton yan. So, 31.629 kilonewton. Then, i-divide natin siya sa area ng volt. Okay, sa isang area ng volt. So, that is 31.629. Okay. That would be 31,629 Newton na lang, no? So that A times 1,000 divided by pi over 4 multiplied by the area of the bolt natin na diameter ng bolt. Diameter ng bolt is 20 mm. Okay, pi over 4. Okay, pi over 4, 20 mm squared. So that is 20 mm. So we'll generate a shear stress of 100.68 megapascal. Okay, 31,629 pi over 4 20 squared. That is 314.15. So that is how we are going for this shearing stress in the ball. So to know the maximum, most critical ball, okay, to know the most critical ball, usually it is the farthest distance. It is the farthest distance from the center of the gravity of the balls up to the A, B, C, D, E. But also, it is the largest, okay, largest resistance. Wherein through, through direct shear ball resistance, we could have vertical and then the horizontal resistance. So with this one, say there's a upward and then going right resistance for the direct. So we will just look on the arrangement of the force resisted due to torsional, wherein it has also resistance of going right and then going upward, which is also the bolt B. Okay, so through that, we could assume that bolt B could be the most critical bolt if they have the same summative. Okay, so that is the first one, the with summative, and then the farthest distance. So we'll just going to calculate the shear force resisted by those two bolts wherein the forces are summative due to direct and due to torsional pares na pakanan. Due to direct and due to torsional pares na pataas. Parang ganun. Okay. So that is the first critical ball, and then the second critical ball is yung pinakamalayo, the farthest. So you will just going to compute the shear resistance of those two bolts, and then kung sinong mas critical is yung may mas malaking kinikerry na shear stress. Okay, so that ends our topic for the connection bolts. So yeah, kindly join again for the next session, okay, in our Zoom meeting.